Hey everyone, welcome back. Ready for another deep dive? Today we're going deep into the world of AI and get this, point tracking in videos. You might be thinking point tracking, but stick with us because this is way cooler than it sounds, I promise. We're diving into a brand new paper, hot off the presses. CoTracker3, simpler and better point tracking by pseudo-labeling real videos.
Yeah, it's cutting edge stuff. And honestly, it's huge for everything from like robotics to how computers see and understand movement in 3D.
Exactly. It's like to make sense of movement, you need to track points, right? But what happens when those points disappear for a bit? Like think about a self-driving car.
Oh, right. It needs to track pedestrians even if they walk behind a tree or something.
Exactly.
Yeah.
Tricky stuff. Well, this paper, they claim they've cracked the code with this new model, CoTracker3. They're saying it's simpler, it's faster, and it's more accurate than anything out there.
And get this, they found a way to train it with way less data than ever before.
Hold on, less data. That's a big deal in AI, right?
Right.
Like usually you need mountains of data to train these models.
You're telling me, normally you'd need millions of labeled video frames. This paper, they got similar results with just thousands.
Okay, now you're speaking my language. Less data, more efficiency, that's what I like to hear. But how did they pull that off?
They use this really clever new training method. It's all about pseudo-labeling. Imagine, right, you've got a bunch of teacher models, each trained a bit differently, like on different synthetic data.
This is like different perspectives on the same problem.
Exactly. Think of them as coaches who've never seen a real game before. Now, CoTracker3, it learns by watching these teachers make predictions on real videos, even if those predictions aren't perfect.
So instead of a perfectly labeled textbook, it's got a team of coaches who are still figuring things out themselves. That's wild. But does it actually work?
That's the thing, it does. And it's not just some small improvement. We're talking about accuracy that's right up there with models trained on those massive data sets we talked about.
Wow. So more efficient and just as effective. That's a win-win. Now, let's talk about CoTracker3 itself. The paper mentioned online and offline versions. What's the deal with that?
Great question. So, not all applications need to analyze an entire video at once, right? Think of it like the online version, it's watching a movie in real time, analyzing frame by frame.
Okay, so it's constantly learning and adapting on the fly, like in those self-driving car scenarios.
Exactly. Now, the offline version, that's more like analyzing a movie after you've watched the whole thing. It can look at all the frames together, go back and forward in time.
And that helps with those moments when a point disappears, right? It can kind of fill in the blanks.
Precisely. It's way better at handling those occlusions, those moments when a point is hidden, than previous models. But here's the kicker. Even though it's outperforming the competition, CoTracker3's architecture is surprisingly simple.
Wait, so it's better and simpler. I like the sound of that.
Right. They ditched some of the more complex modules that previous models relied on. Turns out they weren't essential for high accuracy. And that simplification is a big part of what makes CoTracker3 so efficient.
Less is more, huh? Elegant design. But I'm curious, how do they even begin to test something like this? How do you measure the performance of a point tracking model?
It's all about standardized benchmarks. Think of it like the Olympics for point tracking algorithms. One of the key ones they used is called TapVid.
Okay, so TapVid is like the ultimate test. What makes it so tough?
Oh, it's tough. Imagine like a montage of all the hardest point tracking challenges you can think of. Fast movement, cluttered backgrounds, stuff constantly getting hidden. A nightmare for most algorithms.
So not your average cat video on YouTube then?
No, definitely not. TapVid, it pulls videos from data sets like Kinetics and Davis. These are like the boss levels of video complexity. They even throw in challenges like RGB stacking. Basically, the model has to track points even with crazy color filters on the video.
Okay, so they really put it through the ringer. How did CoTracker3 hold up under pressure? Spill the tea.
It crushed it. Even when they just trained it on that synthetic Kubrick data, it was right up there with the top models. But when they added in that real-world video data, that's when things got really interesting.
Right. They had a whole table in the paper, table 1, I think, showing how CoTracker3 stacked up against other algorithms like Taperture, Locotrack, even Bootstrapper, which was like the reigning champ on TapVid. And the results, they were impressive.
Totally. We're talking significant jumps in performance, like across the board. Especially in metrics like average Jacquard or AJ, that's the overall accuracy. And occlusion accuracy, OA, that tells you how well it handles those disappearing points.
And just to be clear for our listeners, we're not talking about tiny improvements, right?
Yeah.
CoTracker3, with that real-world data, it was blowing away the competition. Even models like Bootstrapper that were trained on way more data.
It's crazy, right? Remember how we talked about CoTracker3 only needing like 15,000 real-world videos for training? Bootstrapper needed 15 million to get to its peak performance.
Okay, that's just ridiculous. So much more efficient. But they didn't stop at TapVid, did they? There was something about a dynamic replica dataset, too. What's that all about?
Oh, yeah. Dynamic replica. That one's all about testing how well a model can handle, well, dynamic motion. Think like trying to track the points on a ballerina's fingers while she's dancing. Really intricate, fast movements.
So like a virtual ballet recital for AI.
Pretty much. Instead of using real dancers, though, they use these crazy detailed 3D models. That way they can like perfectly control the movement and make it super challenging.
And I'm guessing CoTracker3 nailed the pirouette.
Nailed it. Table 2 in the paper, it shows all the results, and yeah, CoTracker3 came out on top again, especially when it came to those tricky occluded points. They use these metrics, delta V's AB and delta Oxy-AB, to show how much better the algorithm's doing, and CoTracker3's numbers, way better.
So it aced the real-world obstacle course of TapFid and the virtual ballet of dynamic replica. But the real test for something like this, it has to be, well, the real world, right?
100%. And that's where Robotap comes in.
RoboCap. Okay, that sounds intense. What's the deal with that one?
Robotap is all about robots, specifically robots doing tasks. Think like sorting packages, assembling things, stuff that needs really precise tracking, and in real time. They wanted to see if CoTracker3 could cut it in a real-world robotics system.
High stakes, then. We're talking about robots that need to see to do their job right. So how did CoTracker3 handle it?
Honestly, still impressive, especially in those situations with occlusions. If you look at Table 2 again, you'll see Bootstrapper with all that massive training data. It did edge out CoTracker3 a tiny bit on tracking the visible points, but when it came to those occlusions, CoTracker3 was consistently better.
So even in a real-world robot setting where accuracy is key, CoTracker3's efficiency and that ability to handle occlusions, it makes it a real contender.
Absolutely. But the cool thing is, this is really just the start. The researchers, they didn't just build a great algorithm, they really dug into how it works. Like, how does its performance change with different amounts of data? How does the choice of those teacher models affect how it learns?
Oh, so there's even more to this story. We got to unpack that. But first, and we're back. Okay, so before the break, we were talking about how CoTracker3's creators, they didn't just stop at building this awesome algorithm. They wanted to get under the hood, right? See what makes it tick.
Exactly. Like, remember how we talked about it being so much more data efficient? Well, they wanted to see how far they could push that.
So did they just like start feeding it more and more data to see what would happen?
Basically, they did these scaling experiments where they gave it progressively bigger data sets of real-world videos, all pseudo-labeled by those teacher models.
Okay, and what'd they find? Did more data just keep making it better and better?
Well, at first, yeah. Like you might expect, the models, CoTracker3 included, they all got better with more data. It's actually in Figure 1, if you're following along.
So even with those fancy training methods, data still matters.
No, for sure. But here's the thing. They hit a point where those improvements started to level off, kind of plateaued.
Really? So, like, it reached its full potential.
That's what they think. They figured CoTracker3, it basically learned everything it could from those teacher models, you know?
Huh. So no matter how many more examples you gave it, it already knew as much as its teachers.
Right. And that opens up all these cool questions like, what if you used even stronger teacher models or like completely different ways of generating those pseudo-labels? It's really exciting to think about.
Totally. It's like, where do you go from there? Now, you mentioned they used multiple teacher models. Did they find some teachers were more helpful than others?
Funny you should ask that. They actually looked into that. Turns out every teacher they used, even the ones that weren't as good on their own, they all helped make CoTracker3 better. They even did this thing, an ablation study, where they removed each teacher one by one.
Oh, like to isolate their impact.
Yeah. And every time they removed one, CoTracker3's performance dropped. It's in Table 5 if you want to see the numbers.
Whoa, so even the C students of the teacher models, they were still crucial. That's really counterintuitive.
It's wild, right? It's like the power of having different perspectives, even if they're not all perfect, it still leads to a better outcome overall.
That's a good lesson for, well, life in general, I think.
Yeah.
Okay, one last thing before we wrap up. The paper mentioned catastrophic forgetting, which honestly sounds a bit terrifying.
Yeah, it's a real problem in AI. Think of it like this. Imagine you've got a model that's amazing at chess, right? But then you start training it on poker. It might actually start forgetting those chess skills it worked so hard to learn. That's catastrophic forgetting.
Ouch, that's rough. So how do you stop a model from basically getting amnesia?
Well, in CoTracker3's case, they found that by isolating specific parts of its architecture, like the parts that predict confidence and visibility, and basically freezing them during that pseudo-label training, they could stop that from happening.
So like protecting those core skills while it learns new ones.
Exactly.
Yeah.
And even that small change, it made a big difference in how well it performed overall. You can see it in Table 7. It's a great example of how understanding these little nuances can lead to some big improvements.
That's so cool. This whole paper, it's just amazing work. CoTracker3 is clearly pushing the boundaries of what's possible with point tracking. Simpler, more efficient, and it can handle those tough real-world situations. It's a game changer.
Couldn't agree more. It really makes you think about what other fields could benefit from this, right? Imagine robots that can work right alongside us, no problem, even in really unpredictable environments, or 3D models that are so real you can barely tell the difference. The possibilities are pretty much endless.
It's mind-blowing. And with CoTracker 3 leading the way for more data-efficient, more robust point tracking, well, I'm really excited to see what the future holds. And that's a wrap for today's deep dive. We'll catch you next time.